Today we'll be talking about zero and negative exponents. Okay, let's take a look at this first example. We have 2 to the 0 power. An example here of how we would get 2 to the 0 power might be 2 to the first power divided by 2 to the first power. Okay, and we know that when we are dividing monomials with the same base, we can subtract our exponents. So we would have 2 to the 1 minus 1. And that would give you 2 to the 0 power. But we can also look at 2 to the first power divided by 2 to the first power. 2 to the first power we know is 2 divided by 2 to the first power, which is 2. We also know that 2 divided by 2 is 1. So 2 to the 0 power would be 1. Okay, let's take a look. 56 to the 0 power. Well, we could follow this same thing here. If I have 56 to the first power divided by 56 to the first power, well, anything divided by itself equals 1. So 56 to the 0 power is also 1. Okay, so any number other than 0 raised to the 0 power is always 1. Okay, and you can see here in number 2 and number 4, it says r to the 0 power, where r is not 0. What is that equal to? Also 1. Again, r divided by r is 1. Same thing down here. As long as your base is not 0, anything to the 0 power is 1. Okay? Now, down here, we're going to take a look at negative exponents. Okay, so if I have 3 to the negative second power, I could get this by doing 3 to the 0 power divided by 3 to the second power. And we know that 3 to the 0 power is going to be 1 based on what we just learned above. And 3 to the second power gives us that positive exponent that we are looking for. So you can rewrite negative exponents using the reciprocal of the base raised to the positive exponent. So we have 1 over 3 raised to the second power. Okay, in number 6 here, 5 to the negative third. Again, we would have 1 over 5 raised to the positive third power. Same thing's going to be with those variables. You have 1 over m raised to the positive fifth, 1 over w raised to the seventh power. Okay, now this is going the opposite direction. What if I wanted them represented as negative exponents? I would do the same thing. I would move it to the top. Okay, I would use the reciprocal, so 1 over d would do d to the negative third power, and then it becomes negative. Okay, again, also you could see d to the 0 power divided by d to the third power. 0 minus 3 would give me d to the negative third. 1 over 12 to the second power would become 12 to the negative second power. Okay. We can take a look at a couple examples down here at the bottom. It says 3 to the second power times 3 to the negative fifth power. Following our multiplying monomial rules, we would keep the base the same. Then we would add our exponents. In this case, 2 plus negative 5 would give me 3 to the negative third power. Okay, and then here in 15, c, my base would stay the same. 3 plus negative 7, I would get c to the negative fourth power. And then my division rules, dividing monomials, my base stays the same. And then I would do negative 7 minus negative 10. And that would give me negative 7 plus 10. Why? to the positive third power. Okay, r to the negative seventh minus negative 1 would give me r to the negative sixth power. Okay, and there are some additional examples here that you can go through and practice.